Hey Al, they tell me you're an expert on Quadra-Trac full-time four-wheel drive. I was wondering if you could give me a quick explanation on how Quadra-Trac works so I could explain it to my customers up in the showroom.
You know, I could sure use some info on Quadra-Trac too, Al, if you got a couple of minutes to spare.
Carol, why don't you tell me what you know about Quadra-Trac, and we'll go from there.
Well, I know that Quadra-Trac is standard on Wagoneers and is optional on other models, and that it provides the driver with optimum traction on a full-time basis on all types of road conditions. Also, the full-time feature and the automatic transmission make vehicles equipped with Quadra-Trac a lot easier to operate than those equipped with conventional four-wheel drive. And I know that this lever operates an optional gear reduction unit, which delivers more pulling and pushing power for jobs like snowplowing.
Okay, let's go to the heart of the Quadra-Trac system to see what makes it tick. The Quadra-Trac transfer case utilizes a drive sprocket, which transfers drive power from the transmission to a drive chain. The drive chain turns a unique differential unit, which passes drive power to the prop shafts. The conventional case, on the other hand, uses all gears to conduct drive power and contains no differential unit.
Why is a differential unit needed in the transfer case?
Here, I'll show you. When any vehicle goes around a corner, the front wheels track a bigger arc than the rear wheels. On a four-wheel drive vehicle, the front prop shaft has to make more revolutions than the rear prop shaft. When a conventional unit is left in four-wheel drive and driven on dry pavement, a condition known as prop shaft wind-up results. The difference in prop shaft speeds creates a wind-up effect on prop shafts and transfer case components. With a conventional transfer case, this condition is avoided by simply shifting to two-wheel drive on dry pavement.
But what about a full-time system with no two-wheel drive mode?
Well, Greg, old buddy, you just hit on the problem that faced the designers. They knew they needed some kind of a differential feature that would allow the prop shafts to turn at different speeds during cornering situations. They knew that if they put a regular axle-type differential between the prop shafts, the system would be useless as soon as one wheel lost traction. The differential would allow all drive power to go to the spinning wheel, where it would be wasted.
How did the designers overcome the loss of traction problem?
Here's how they solved the problem. A cone clutch is splined to each output shaft. Preloaded Belleville-type springs keep the cone clutch in contact with the differential case sprocket. When a wheel loses traction, the springs keep the output shaft and prop shaft locked to the differential case sprocket until the preload of the springs is overcome by drive torque. So, because this axle cannot absorb all of the drive power, the axle with available traction receives enough drive power to propel the vehicle.
So, if the vehicle is traveling straight ahead on dry pavement, the differential divides all drive power equally between the front and rear prop shafts. Have I got that right, Al?
Yep, and the cone clutches are in contact with the case sprocket, but are really waiting to do their thing.
And when the vehicle is driven around a corner, the prop shaft wind-up overcomes the preload of the springs, the cone clutches slip, and the differential allows the prop shafts to turn at different speeds.
I couldn't have said it better myself, Carol. And remember, when a wheel loses traction, the axle with available traction receives drive power up to the point where the preload of the springs is overcome. Any additional power past this point is not applied to the axle with traction because the differential is then taking over. But if the driver applies excessive drive power now, he may damage the cone clutches.
Al, I know that the Quadra-Trac emergency drive switch, which is located in the glove box, should be activated during certain severe driving situations. When should I tell my customers to switch to emergency drive?
Well, what the emergency drive system does is bypass the differential and lock the front and rear prop shafts together. This should be done when all four wheels lose traction, or when the vehicle becomes high-centered, or when a prop shaft or axle becomes inoperable.
What happens when the switch is activated, Al?
Engine vacuum is passed through the switch to the apply side of the control diaphragm, which is attached to the rear transfer case cover. Then, atmospheric pressure, working on opposite sides of the diaphragm, moves the diaphragm rod forward into this position. As you can see, the shift fork, which is connected to the diaphragm rod, has pushed the lock-up hub forward so that the rear output shaft is locked to the rear end cap. Because this rear side gear is locked to the differential case sprocket, none of the gears inside the differential can turn. Therefore, both output shafts turn at the same speed. The diaphragm rod has also contacted a ball in the indicator switch, causing internal contacts to close and the dash light to come on.
Al, one more question. Can a reduction unit option be installed here at the dealership?
You bet. As you can see, the reduction unit simply bolts onto the rear of any Quadra-Trac transfer case.
Well, thanks for the lesson, Al. Now I'll be able to explain the advantages of Quadra-Trac to my customers from a technical point of view.
Anytime, Carol. How about you, Craig? Did I help you at all?
You sure did, but listen, how about a few service tips while you're in the mood?
Well, the majority of Quadra-Trac problems are caused by incorrect driver operation, incorrect transfer case lubricant or low lubricant level, mismatched or improperly inflated tires, or vacuum-related problems in the emergency drive system. Your best bet for service help is the Jeep Technical Manual. In addition to disassembly and reassembly steps, the manual provides time-saving diagnostic charts for transfer case and emergency drive problems.
I've heard about a stick-slip noise that sometimes occurs during cornering or parking. What's the deal on this?
Well, the cone clutches receive lubricant when they release and apply. During extensive straight-ahead driving on dry pavement, they don't do this, and lubricant is spun off of the cone clutches and their mating surfaces. Then, when the vehicle is driven around a corner, the dry clutches release, causing a growling or rasping sound. Now, some stick-slip noise is normal, but if it doesn't disappear after several turns, corrective service is required. And Greg, the most important factor in preventing a stick-slip problem is using the right lubricant, Jeep QuadraTrac lubricant. If you do come across a vehicle with a stick-slip problem, try draining the case and refilling it with Jeep QuadraTrac lubricant. Remove the fill and drain plugs, and if a reduction unit is present, loosen the attaching bolts so the lubricant can drain out. Then, tighten the drain plugs and reduction unit bolts and fill the transfer case with 2 quarts of Jeep QuadraTrac lubricant. Fill the reduction unit with 1 pint of lubricant. Tighten the fill plugs. Then drive the vehicle in circles, clockwise and counterclockwise, but don't hold the wheel over against the lock or you may damage steering components.
Al, why drive in circles?
Now, this causes the cone clutches to release and apply, forcing lubricant throughout the differential. If after this procedure excessive stick-slip is still present, the differential unit may be damaged or gummed up. You can check the operation of the differential by performing this torque bias test. With the emergency drive disengaged and the transmission in neutral, have a helper hold the brakes. Then, turn the rear yoke retainer nut in a clockwise direction with a torque wrench. If the clutches slip at a figure less than 80 foot-pounds, the differential unit is faulty. If they don't release before 171 foot-pounds are applied, the differential unit is probably gummed up or defective. Greg, I think you should know about the importance of drive chain tension. A lot of transfer cases have been needlessly replaced because of noises created by loose chains. With the transmission in neutral, you can check chain tension by threading this special gauge into the inspection hole. The chain on the left has adequate tension, so the plunger extends past the end of the gauge. But the chain on the right is too loose, so the plunger does not extend past the end of the gauge.
How about showing me how to replace a drive chain and inspect the differential unit? And now that you've got my curiosity up.
Okay. You can service the chain and the differential by simply removing the rear cover assembly. After draining the case and removing the reduction unit, mark and remove the emergency drive diaphragm hoses. Then, disconnect the indicator switch wire and the speedometer cable. Next, disengage the parking brake cable guide from its pivot. By the way, if you're working on a CJ7, place a support stand under the transmission at this point and remove the rear crossmember. Now you can remove the rear cover assembly bolts and then the rear cover assembly itself. Then, with the cover assembly on the bench, remove the rear yoke with the special wrench shown here. On the right here is an important seal you'll find under the retainer nut washer. Don't forget to put this seal in when you reassemble the unit. Next, remove the snap ring that holds the hub to the drive sprocket. If your vehicle is equipped with the reduction unit pinion carrier shown on the right, it will be used in place of the hub. Place a wooden block under the drive sprocket and remove the rear cover from the drivetrain.
If you're just replacing the chain, you can put the new chain on now and begin reassembly, right?
You got it. Now, if your torque bias test or a persistent stick-slip problem suggested problems within the differential unit, mark both end caps to the differential case sprocket. Then remove the end cap bolts. Next, you can remove the internal components. But here's an important point, Greg. Always keep the front components separate from the rear. They must be in their original places after reassembly. The pinion mate shaft lock pin is removed next. You may need a 1/4-inch pin punch for this step. Then, the pinion mate shaft can be removed.
Now, what are we looking for here?
Well, if you find varnish or other residue on the components, clean them thoroughly, Greg. Then, look for damaged cone clutches and broken gear teeth. Also, check for ridges on gear teeth, loose pinion mate shaft bore, and thrust washers and preload springs that have lost their conformity. Finally, check for any galling or scoring. If any irregularities are found, the differential unit must be replaced.
And if everything's okay, the differential can now be reassembled, right?
Right, Greg, but here's an important point. Both output shafts must be installed before the end cap bolts are torqued to 27 foot-pounds. You should keep an extra shaft around the shop for these situations. The transfer case can now be reassembled by following the procedures outlined in the Jeep Technical Service Manual. While we're at it, Greg, let's take a quick look at reduction unit service. If you ever have an internal problem with a reduction unit, you start the disassembly procedure by removing the PTO bolts and the snap ring. Then the housing can be separated from the gear train.
Is there much trouble with the shift components and the housing itself, Al?
Not much, but if you come across a reduction unit problem, it's usually in the gear train itself. Once the housing is removed, the gear train components will separate and you can look for any damaged components. To reassemble the gear train, simply build the train piece by piece on the bench in the order shown here. Then flip the gear train over onto a punch in a vise. The housing and snap ring can then be installed.
Al, how does this unit create a lower gear ratio?
Well, here's what happens when the reduction unit is in neutral. The sun gear, in blue, receives drive power from the transmission and passes it to the pinion gears, in yellow. The power is then transferred to the ring gear, in green, which is turning free. So, because no members are locked together, no drive power is passed on to the Quadra-Trac transfer case. When the unit is put into low range, the ring gear is locked to the case. The power from the sun gear forces the pinion gears to walk around the ring gear, carrying the pinion carrier in red with them.
Oh, yeah, and the pinion carrier is attached to the Quadra-Trac drive sprocket, so if the carrier turns, so does the drive sprocket, right?
Right. And because the sun gear makes about 2.5 revolutions for every one the carrier makes, we have about a 2.5 to 1 gear reduction. In high range, the ring gear is unlocked from the case, and the ring gear, pinion carrier, and sun gear turn as a unit. So now we have a 1-to-1 gear ratio. One more thing, Greg. The older reduction units were operated by a cable, which sometimes creates problems. This kit allows you to convert older cable units to the more efficient lever and link rod system. Well, that's Quadra-Trac in a nutshell, Greg.
One more question, Al. How'd you come to know so much about Quadra-Trac?
Well, I'd like to say it's because I'm simply a genius. But the truth is, I attended a mobile school session on Quadra-Trac.
Yeah, I guess it paid off, huh? Hey, listen, Teach. Today and today only, I'm going to spring for the coffee just to show you that I appreciate the lesson.
Hey, you're on. The handy reference book that accompanies this program contains highlights of this film, plus additional Quadra-Trac information and diagnostic charts.